In this video, we're going to be talking about polygons, perimeter, and tessellations. So I just took these pictures directly out of your book because they summarize everything that we need. So first, a polygon is nothing more than a shape. Now, we have rigid shapes or regular polygons. So regular polygons are the ones that form these special shapes. So if it has 3 sides, it's called a triangle. 4 sides, we consider it a quadrilateral. 5 sides, pentagon, and so forth. Now, what we can do is we can break this down a little bit further. Like, for example, we already went over the different types of triangles: a right triangle, scalene triangle, isosceles triangle, and the equilateral triangle. But we also have different types of quadrilaterals or 4-sided shapes. So we have a parallelogram, and what makes a parallelogram so special is that we have 2 lines of same length and then another 2 lines of same length, and their opposite angles are the same as well. Okay? A rhombus is nothing more than a square where you kind of like push the top of it. So you can see how it's kind of like angled here. A rectangle, that's the quadrilateral that we're really familiar with, just means that you have 4 right angles and opposite sides are parallel and have the same measure. So this and this have the same measure, and then this side and this side, they have the same measure as well. A square is just a very special rectangle in which all the sides are the same exact length and you have all 4 right angles. And finally, a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. And that's going to be right here. All right. Now, perimeter. If we want to think about perimeter, and I know there's all these different formulas for perimeter, but perimeter really, at the end of the day, all it means is just to sum up the distance of all the sides. So, for example, this rectangle, if I labeled the rectangle length and width, then we've all seen this formula: perimeter equals 2L plus 2W. But like I said, at the end of the day, perimeter is nothing more than summing up the distance of all the sides. So if you were to kind of place yourself right here on the corner and just start walking the perimeter of this rectangle, you would have walked a distance of L plus W plus L again, and all the way back to the start, 4 plus W. And that's how we actually come up with 2L plus 2W. But like I said, end of the day, doesn't matter because you were just summing up the distance of all the sides. Now, the next thing I want to go over is going to be the sum of the measures of a polygon's angles. So if we look at this picture right here, all right, notice that we have a polygon with 4 sides. So 1, 2, 3, 4 sides. Now, if I wanted to find the sum of all the angles inside of this, I'm going to create triangles, because what we know that all the angles, 1 plus 2 plus 3 in a triangle, must total up to 180. So if I look at this very first example here, notice I can form 2 triangles. So here's like the first triangle, here's the second triangle. So therefore, the angle sum is going to be 2 times 180, which is 360 degrees. I'm going to make my marker here a little bit smaller. But here's where you can kind of take this and maybe you can start to develop a pattern. So in the second example, we could form 1, 2, 3 triangles. So it's going to be 3 times 180 which is 540 degrees. Same thing with the last one. 1, 2, 3. So we can form 1, 2, 3, 4 triangles. So 4 times 180 equals 720. And we can develop a formula here. And here's what that formula looks like, all right? So I'm going to erase everything up top. Because when we look at the very first shape, notice we have 2 triangles, right? But we have 1, 2, 3, 4 sides. So 4 minus 2 times 180. Now, 1, 2, 3, 4, 5 sides. So 5 minus 2 times 180. And finally, 1, 2, 3, 4, 5, 6. So we have 6 minus 2 times 180. So if you notice, this whole formula kind of stems from the number of sides minus 2 times 180. Okay? And that's what this formula is saying right here. The sum of the measures of the angles of any polygon with n sides is n minus 2 times 180. So if you had, let's say, a dodecagon, which is a 12-sided shape, so when n equals 12, we get 12 minus 2 times 180, or 10 times 180 equals 1800. So the sum of all of the measures of the angles in a dodecagon has to be 1800. Now, the last thing I want to go over is going to be tessellations. So tessellations, we've seen tessellations before. Like a lot of times you see them in art or in tiling, okay? So like art or tiling. And what I mean by tiling, it's like floor tiles, right? So I took this picture directly from your text. And these are all examples of different types of tessellations, okay? Now, what makes a tessellation so special is the sum of the measures of the angles that come together at each vertex sums to 360 degrees. So that is a requirement, all right? Now, if we look at this very first example here, all right, and I'm going to go ahead and just copy another picture out of your book. And let me kind of copy and paste this for us real fast. Here's exactly what that definition above is saying. It's saying if you take this angle, oops, let me get a red marker out. If you take this angle right here, which is 135 degrees, this angle right here, which is 135 degrees again, and then this angle formed by the square, which is 90 degrees, and you totaled all these up, that equals 360 degrees, which is the requirement. It has to do this. So if you have, let's say, some shapes that you want to put together, the vertex at where they meet, if they do not add up to 360 degrees, you can't do this. And that's this example right here. So let's say we wanted to try to form a tessellation using pentagons. Well, notice here, I have I have 3 pentagons. Each angle inside is 108 degrees. Well, notice when you can't fit them together because you're going to end up with a 36-degree gap. All right. And how do we find this? Well, an easy way would just be to use the formula that we have and divide it by the total number of sides of the shape that you're looking at. So in this example, it would be 5 minus 2 times 180 divided by 5, which turns out to be 108 degrees. And 108 degrees will not work with 360. You will end up with, like I said, that 36-degree gap. And that's going to be it for this video. It's a very short one. So good luck.